Good afternoon, sir. This is the topic for our project, Smart Weather Monitoring System for Cloud Training. Right. These are our group member. I'm Kit, and these three will introduce themselves later before they present.
Hello, my name is Group7 and I will present about the architecture diagram for smart weather prediction system. So let's begin with an overview for the system. So our smart weather prediction system integrates various sensor together data, predicts weather condition using AWS service and control drying rate accordingly. So we utilize four sensors which is light intensity, wind speed, temperature and humidity and UV sensors. These sensors collect data every 15 seconds which is then transmitted to the AWS IoT core. And upon receiving the sensor data, the AWS IoT core triggers a Lambda function. This function checks a DynamoDB semaphore table to ensure there are no other Lambda is using shared resources. It then invokes a SageMaker's endpoint for weather predictions. And the prediction results is compared with the current state of the drying stack stored in DynamoDB. If action is needed, such as moving in or out, it updates the current state table. Users are notified via email through SNS with an option to manually correct predictions. To improve prediction accuracy, we record sensor data and predictions result in DynamoDB. Incorrect predictions trigger the recording of training data for future AI model improvement. And monthly performance metrics including correct prediction count, wrong prediction count, and model accuracy are visualized for user. QuickSight is utilized for data visualization with DynamoDB string to an S3 bucket from processing. So that's all for the architecture diagram. Thank you. And now I will explain about the system configuration manual. So first is to create a S3 bucket to store the training data, which is the step 1 is go to S3 and click create bucket and type in your desired bucket name under the bucket name field. And other setting can leave as it is and click the create bucket and click on the name of the bucket you just create and click upload and drag the training file from your device local storage to the blue dotted line field. And the training file will be shown under Files and Folders and click Upload. And the training file successfully upload to S3 bucket. And next is set up the Amazon SageMaker. And at the homepage, search Amazon SageMaker. And at the menu of SageMaker, click Domains. And click Create Domains. And choose Setup for a single user. Then click Setup. And wait for the domain to be ready. When the domain is ready, click Add User. And specify the name of the user. Other settings can leave as it is. And click Next. And then click Next again. And for the canvas setting, leave all settings as it is and click next. And user will successfully create at the launch menu and click canvas. Wait for canvas application to be successfully created. And this is the homepage of canvas application. And choose data wrangler at the side menu and click create a data flow. And click create and click the import data. Choose tabular from the drop down list and choose Amazon S3 from the data source drop down. And click the bucket name that has training data stored in it. And choose the training data from the bucket and click import data and click add step and choose the process numeric under the add transform and choose standard scalar for the scalar field and add in the column to be transformed at the input columns field by ticking them. And tick center and scale, then click add. And the data under the chosen column will be successfully transformed and choose the add step and choose encode categorical under add transform. And for the transform field, choose one hot encode and choose the input column to be transformed and click add. And the column had been transformed, click create model and click export and navigate back to the home page of the canvas application. Click datasets from the side menu and click the dataset you have just exported and click create a model and click create again. And at the target column, select the desired output column and drop column by untick them in the green square pane and click configure models and choose data split from the side menu and change the value under the training set field to 70 and the field under the validation set will be updated automatically and click save and click quit build and wait for the model to be built and the model is successfully created and click deploy. So name the deployment as you wish under the deployment name and choose ml.m4.slarge under instance type and click deploy. And model deployment will usually take a few minutes, so wait for the status to become in service. And sample of a successfully deployment model, the one with the in service status. And back to the SageMaker dashboard at the AWS console and click Inference at the side menu. In the drop-down list, click Endpoints. You will see your successfully create endpoints.
Hello everyone, I'm Chasun Yan. Now I'm gonna introduce problem statement. In our usual life, crowd driving face challenge of weather changes and the trouble of manual monitoring. Besides that, modern fast-paced life exacerbates this challenge. So we need to reduce human and mental resource consumption and improve efficiency and convenience. Our objective is to design an intelligent self-driving system leveraging innovative technology. And the solution is to deploy environmental sensor network to monitor weather data in real time, use the cloud analysis to predict weather changes, and notify user of optimal driving times, and user can manually trigger cloud collection and provide feedback data to improve AI model so that the next time the model will be more accurate. Then I'll introduce setup IoT core and setup connection between IoT core and SameMaker model. First, go to AWS Cloud, go to IoT core. Click Connect one device. Copy the command of step 4. Run command with proud and check connection. After that, create a things with sensor name. Select Windows and Python. Download connection kit. Unzip it. Then here is the detail of connection kit. Open the start with Notepad. Make sure the path is correct. If not, change it. And then open PowerShell, copy and paste the code to run to get the permission. Run the start with PowerShell, then we will send the hello world to the SDK test Python topic. Go back to website just now, we will see that we successfully get the hello world output. AWS IoT device SDK Python v2 will be generated after running start PowerShell document. Create a sensor Python and change the path in start PowerShell document. Then modify the code of part and staff and copy to sensor Python for simulate multiple sensor sending data to IoT core SDK test Python topic. After that, go to IoT core. Find the rules, create a rule, fill in rule name, configure SQL statement to capture the data in topic. Decide rule action as lambda. Select a lambda function or create one. Confirm and create. Then we create a lambda function. First go to lambda. Create a lambda function, select Python, then continue. We can create add trigger, but it's not always a necessary action. Under configuration, click general configuration, then click edit. Set time up to 1 minute, then click save. All lambda functions created in this system will have 1 minute timeout. After that, we continue to set up connection between IoT core and SameMaker model. Select AWS IoT as trigger. Select rule create from IoT core just now. Then we successfully configure trigger and the lambda function will be run every time IoT core trigger. Do the following step if a SameMaker model was created but not deployed. Go to SameMaker, find and create models, select the trend model, create an endpoint. Create and configure endpoint, select provision and continue. Create production variants, add the models, then click create endpoint. If a SameMaker model is successfully deployed, continue from here. Make sure sensor Python in local is subscribing the SDK test Python. Then we back to lambda and modify the code. The lambda function get data from SDK test Python topic and transform data format for SameMaker to predict and return the output. Then lambda will send the SameMaker result to SDK test Python topic. Then the result will be shown in PowerShell when running start PowerShell document because subscribed to the topic. Here's the lambda code and the continue part. Here's the sensor Python document and the continue part. Make sure to install necessary Python library below with type the following line in your command prompt. If you want to simulate the sensor data passing using the Integrate Development Environment IDE, pass the following code into any Python IDE and click run. Here's the code. Here's the continue part. Thank you. That's all for me.
Next, we'll create a DynamoDB table to record the current state of the driving track. So first, go to DynamoDB and here click table, click create table. Give your table a name, partition key name, then click create table. And table successfully created shown here. So next, we will create an item in the DynamoDB table. So click explore item, the table you want to create an item into, and click create item. And give your partition key a value to identify that item. Then add new attribute if you want to add new columns. Give your attribute a data type and give your attribute a name, a value. Click create item. So you'll see a new item is being created here. And next, we'll need to give the lambda function permission to read and write dynamic tables. So go to test SageMaker, click configuration, permission, click this I, and you'll be redirected to the IAM page. And here, click add permission, create inline policy. Then the service you want to give the permission for, which is DynamoDB here, and click next. Then allow all actions, give all resources for easier setup purpose. Then click next and give your new inline policy a name and create policy. So you'll see your policy successfully created here. Next, we'll move on to the setup of SNS. So go to SNS and give your topic a name, the next step. Then choose standard, click create topic, click create subscription. Remember to copy this ARN and paste it here. Protocol choose email, and the endpoint you'll just key in the email you want to use to subscribe to SNS. So here will show a subscription successful message, and then the status is pending confirmation. So you need to go to your email, click on the confirmation email, click confirm subscription, and yeah, subscription confirmed, and the status will change to confirm. So next you'll need to give the IAM permission for both the test SageMaker and both Lambda function to have full access to the SNS. So we can just follow the steps in the previous slide. You just go to the Lambda function, click configuration, click permission, and then you just click on the role and you will be directed here. Here you just click create inline policy and give all permissions about SNS and give your inline policy a name, then it will do shown here. Now we'll implement a function to the SageMaker Lambda function where it can check the current state of the drawing rack from the current state DynamoDB table. So here's an example. If the prediction result is 1, which means raining, the current state is 1, which means the drawing rack is outside, then change the current state to 0 and send message to the device to move the drawing rack inside. So the following slide will provide a few functions to read and write the DynamoDB table. So we'll need to paste these codes into the test SageMaker Lambda code space. The SNS triggering, which will send message to user, will also be handled by the codes in the following pages. So this is a function to read data from DynamoDB table. So we create a DynamoDB object here. Name of the table you want to read. The partition key of the item you want to read. Use this getItem function. And this is the response. So we need to extract the item from the response and then specify which column we want to read, which means attribute. And this is a data type. And this is the function to update an item in the DynamoDB table. So again, create an object, name, key, and here we use the update item function. So this is the attribute name you want to make changes to. This is its new value, data type. And next you need to put this code into the Lambda handler function. So basically here is included with the codes to call these functions. So this is to extract the prediction result from the response message from SageMaker AI model. And here we create a SNS object that later we can use to send message to the user. Then we use the if-else logic to check whether we should move in or move out the drawing rack or make it remain. So we will need to update the return message also because originally we only return the result. So now we will need to return the action to be done by the drawing rack, whether to move in, move out, or remain. And this current state is just for checking purpose to make sure this is correct. And next, to avoid race condition, we will need to create a semaphore, which we will implement it by create a semaphore DynamoDB table because the current state table is actually a shared resource. So create a semaphore table. This send it to initialize to 0 or else the system cannot run. And this is a function to read semaphore, function to write semaphore, same as the previous read and write function. And this is how to use this function. So first, the Lambda will check the semaphore table to see whether the shared resource is locked. And wait until it is unlocked, then the Lambda will lock the shared resource. And after using the shared resource, the Lambda will release it so that other Lambda can use it. The test SageMaker Lambda will also have a function to record the current sensor data for training data recording purposes. So to do that, we will need to create a current sensor data table, initialize it like this. Then this is the function to write the current sensor data to DynamoDB table. So actually it's quite same to how we update the table item just now, just that now we need to update more columns, so more lines in the update item function. And this is the code to call this function, paste it into the main Lambda handler function. Then for data visualization purpose, we will need to create a DynamoDB table to store this correct prediction count in percentage, wrong prediction count in percentage, total number of prediction, and model accuracy. So again, create a data visualization table, initialize all these columns into 0. Data type is all number. And then this is a function to extract the accuracy of the model from the return message of the SageMaker AI model, which is done here. That is to extract the model accuracy. And this update item is actually quite same to the previous item updating functions. So this is a function to update all other columns in the data visualization DynamoDB table. So actually also quite similar to how we update the item in the table just now. And then add this calls into the lambda handler function, which is to call these two functions. Next, to enable the user to move in and move out the drawing rack manually, we will need to create a lambda function named move rack, and we will need to give this lambda function all permission for DynamoDB. So we will need to paste these codes into the lambda code space, and in this codes, the calling of necessary functions and also the if else logic to determine whether to move out the drawing rack or move in the drawing rack, and also the SNS object creation to send message to user, all are being included here. So this lambda function can read and write on both semaphore, current state, and data visualization table, and the codes to call these functions already be included here. And then the following codes are the function to do this action, read and write. So read and write current state, read and write semaphore. These are read and write on the data visualization table all are quite similar to the previous ones, just that here we need to change a little bit here. And the move_read lambda function will insert training data into the training data DynamoDB table by reading the current sensor data table. So we will need to create a training data table. So apart from location is in string, other are all in numbers. And this is a function to insert item into the training data table. Because it is in this table we need to keep insert new items, new row of items, rather than just use one item and keep updating it. So we will use this dynamo.putItem function. Okay, so the other thing like create an item, create a DynamoDB object, name, key are just pretty similar to the previous ones.
Hi, my name is Edwin Wong Chen Jiang. Today I'm going to talk about the API gateway services to enable users manually trigger the device to move the drawing rack. So we choose the API gateway service and create API, and we build API. Then we put the name and create API. After successfully created, we choose the method type if any and lambda function. And we choose the move break from the drop-down list and create method. Yes, it is great. Then we click the deploy API. So in the stage, we choose for the new stage and name the stage name and deploy. So the new stage was successfully created. To call the API to invoke the move break lambda function, we copy the invoke URL and paste it on the browser and load it. So we can see now in the function, there is a trigger now. As the data visualization will be updated on a monthly basis, the event bridge will invoke a lambda function to set the data to 0, except for the transition key, which is primary key. So we now create a function named monthly update. So every first of the month, the data will be initialized to 0. So now we give the lambda function with all permissions for DynamoDB. Just paste the code to the lambda function. Now we set out the event bridge. In the services of event bridge, we choose for the schedules under the scheduler. Then we create schedule. We give it a name and choose the recurring schedule. Choosing for the Chrome-based schedule and expression to 0001, which is the first two is minutes and hours, and the third one is month. So we basically refresh the data once a month. So click the next, and we select the lambda as the target to invoke. So we choose for the function monthly update, then click next. Leave the setting at the create schedule. It is successfully created now. So for the data visualization, we create a lambda to visualize it. So basically we create from scratch, and we assigning the permission. It's created now, and we paste the code to the lambda function. This is the code. So now we set up the DynamoDB stream. We select data visualization table. Under the export and streams. Then we click the turn on in the DynamoDB stream details. Choose the key attributes only and turn on stream. So in the DynamoDB stream successfully created, we click the create trigger. Select the function you want and create trigger. It is successfully created also. So now you will see the DynamoDB stream actually is the trigger now. Next, we create an S3 bucket and link to the Amazon QuickSight for data visualization. So create an S3 bucket and name the bucket uniquely. So leave the details, the settings, as it is. After created, upload the file to the bucket for QuickSight. We upload a manifest file and an AWS test file. So this is the code for the manifest file. It links the AWS test file here inside. So we set the permission for new S3 bucket. Click the manage. Select the S3 bucket and select the bucket we created just now. Now we create a new data set for data visualization. We copy the S3 URI in the S3 bucket, which is the manifest file URI. Then we paste the URIs here, and it is connected. The data set is created now. So actually, the data in the DynamoDB will be fetched to the S3 now. Then from the S3, it refreshes the data to the QuickSight. So from the data set, we click the edit data set, and it leads to here. The data is shown here actually from the S3. So we click the publish and visualize. So you can see now the data in S3 actually visualized here. You can create a table or chart for better visualization. So if you have anything updated in the S3, you just click refresh now. Then for the full refresh, okay. Then the data is updated here. That's all for me. Thank you.
Now I'll make a demo or simulation on how our system runs. So first we need to check on something. Current state of the drying rack 0. Data visualization. All column initialized to 0. Training data 2 column. Okay, so we'll run the Python code for 3 times, which means 3 set of sensor data will be passed into the IoT core. So the SageMaker model will be making prediction for 3 times. First prediction, model output 0, current state 0, so the drying rack remain. Now I will try out the API to manually move the drying rack. Okay, successful. So as you can see here, current state changed to 1. Action, move it. Then the model do prediction again. Model output is 0. Current state is 1, so the drying rack is move out. So the drying rack had been moved for 2 times. Okay, so just a summary. We have done 3 prediction, 2 correct, 1 wrong, because I have manually moved the drying rack for 1 time. So that wrong prediction will be added in the training data. So it should have 3 training data. Then because the state of the drying rack changed for 2 times, I should receive 2 notification. Okay, correct. And here, 3 rows of training data, correct. And data visualization table, 2 correct prediction count, 3 total prediction count, 1 wrong prediction count, model accuracy 0.89. Okay, 0.89, all correct. So let's move on to the data visualization. So we will need to refresh the source first. Okay, wait for the refresh to done. Publish and visualize. Okay, so you can see correct prediction percentage, model accuracy, wrong prediction percentage. So same as here. Data visualization table will be cleared monthly, which means the value of each column will be initialized to 0 at the start of every month. So now we will test out if the Lambda function that handles this work properly. So test. Okay. So now we see that the value of each column had been initialized to 0, which means this lambda function works properly. All things in our system work properly and correctly, which means our system is working fine. That's all from us. Thank you.